Hello everybody, and I want to talk a little bit more about flotation and Archimedes' principle. So we said that Archimedes' principle says that the weight of the fluid displaced is equal to the buoyant force. So if the weight of the fluid displaced is greater than or equal to the weight of the object, it floats. So piece of tin foil here, right? Curl it up into a ball. If I drop it in the water, you can see here that it floats, or hopefully you can see here that it floats. Let me pull this over so you can see that my tinfoil is floating. So if I push down on the tinfoil, right, submerging more of the volume, what happens is it pops back up. Because if when I submerged more of the volume, the buoyant force actually gets a little bit bigger, right? So that's enough to keep this object floating. So apparently we could say that tinfoil is less dense than water. All right, because it was able to float. Now, a couple of things here. I went out today. I know I shouldn't be going out, but I needed stuff for this video. Got myself some Play-Doh, right? Got a little ball of Play-Doh here. It's about half of a container of Play-Doh. And if I put it in the water, boom, right? Obviously, Play-Doh is more dense than water is because this solid mass of Play-Doh, and it's a bit gross, sunk. But here's the thing. If I take an equal mass of Play-Doh, right, which I did, and I formed it into a little thing here. Now, I haven't changed the density of Play-Doh. Play-Doh is Play-Doh is Play-Doh. Every bit of Play-Doh is the same density. What I've done is I've made the shape such that when I put it in the water, it displaces more volume, and boom, it floats, right? And it floats pretty well there. So it's not that I changed the density of the Play-Doh, but what I've done is I've changed the volume of the liquid that it displaces by hollowing it out. Now, in the videos you watched yesterday, they talk about how that is reducing the quote-unquote effective density of the object. So rather than thinking about density in terms of the volume of the object and the mass of the object, it's about the volume that you can carve out here, so that it's about the volume of the liquid that you displace that's important, not the actual volume of the materials that you did, because this material and this material is the same amount of stuff, but just the shape is a lot different, that this allows for a larger volume of liquid to be displaced. And that's how a boat works, right? A boat is not just a solid chunk of stuff. A boat is going to hollow it out in some way, shape, or form, such that when this is placed into water and it's submerged, it displaces a lot more volume than this solid mass would displace. So that's what I want you to think about tomorrow when we start our boat building project. Now, I'm nice. Our boat building project is going to use tinfoil, which we saw is already less dense than water. So we know just the tinfoil itself will float. Now what we're going to try and do is maximize the weight that I could put on the tinfoil and cause that to float. So that's what we'll be talking about tomorrow.